Good evening, everyone. Ngasi ko into with the mechanical properties of solids ni ka. So let's start today's class. Solids kita with ni. So kadai chat crane this is layer ka properties. So mechanical properties of solids ko ika chapter zigi maming je ka. So stress strain curve ka ika layer ka. Then they ka layer elastic moduli na ka. Elastic modulus. Singular jana modulus ka. The plural jana moduli elastic moduli ka layer. So and it's a very small chapter. Yamna pick chapter ni ka. So let's do it ka. Okay, fine. Ka, we'll do it. Chapter number kya audience is chapter number 8 la. 7 la. 1 second. Sina kay gumba sida chapter number 9 or chapter number 8 ka. Chapter number 8 mechanical properties of solids ka. Mechanical properties of solids. Okay, now how is it called? Mechanical properties of solids. Now, we have the mechanical properties of solids. The term is deformation. Because solids we have the deformed the solids we have the magi own property ka. Amana we have the mangunda hanagi configuration or hanagi shape or hanagi size to the restore torokpagi masada property ama yauzayeba ka adudune kwintam godise ka. So deformation in solids haitare. Deformation in solids. So deformation in solids we have the we can divide the deformation in solids into 3 types ka. Deformation in solids ka ahum thokna ko study to way ka ahambada longitudinal quite laiba adum ahumak lai ka longitudinal deformation. The second tangential hierarchy sharing hierarchy ka tangential or sharing have got SHEAR ka shear to ka twist or turn to sharing. So I'll say she's a kanjalam do malen the ka in is I don't know what to do with the we just wait them kanjalam kanjan music kanjan danaba sing with them in a way you go ka she already kanjalam ka anyway fine ka yare. So tangential deformation or sharing ka. Then we have the volumetric deformation. Volumetric deformation ka. Now volumetric deformation we have the pochi compressed of the my volume or hangat hanbada ka adu volumetric deformation ka weba ko ma'am sir na haji tabra yariba
sorry sir
yari ka okay fine. Right ka ma'am amtang taita de namtang kumaune Kavita Shivani Lakshmi Setabos Sinthoi Christina Anjali tabra lone
Hi, sir.
Okay, fine. Let's continue. Deformation in solids. Audai mathang da kida we have matam da deformation je koi na tam ge har ga di ka kai amuk tam ni ha matam da kai da wa magi property am le solids ko dingi ka elastic property na elastic property have the kai no have the tendency to return to its original configuration ne ba ka aduna let's define this ka. Elasticity harge ka. Elasticity है जी tendency of a solid to regain its original configuration. Its original configuration. Yare ka elasticity है जी का दुना सी सुमाइन ले elasticity की क्या नोज़ी का definition से tendency ka elasticity. Now mathang da kay plasticity hargadi kay na. Plasticity hargadi kay ba opposite ay tare ka opposite of elasticity. Have the tendency to kay ba not regain its original configuration high plasticity di ka. Mathang da akoina stress and strain ka. So strain antamazi strain habdi kay na the ratio of change in configuration to the original configuration now that strain of the last oina stress na amagong tamji ka stress in a kaino habada it is the restoring force per unit area now sigina areas sisi kay we have the kuina longitudinal dana kay oini tangential or sharing dana kay oini volumetric dana kay oini have sa si loina ma khenai areas gyan dai ko sa aduna sigi area si akuina kay longitudinal deformation tamakko matam dana area of cross section la kaduini tangential deformation tamakko matam dana sigi area si tangential area la kaduini ko then volumetric deformation tamakko matam dana surface area la kani bu ko kaning luzu join tawge hare ko so sir na sida ko sigi page sida first page ni ko sigi za call torquiten je ta sana class ko anyway fine so kida we have the mechanical properties of solid set yam live chapter ni yam pick chapter ni ko sir na pi ba sigi definition kharaje sigi ji khang daga di we cannot proceed auna kaino ha matam again stress ka strain ga ji kaino khang de stress harga force per unit area dang highway ya de ko stress hargadi restoring force per unit area neba restore taunaba mangonda kai toba force ama masa mathanda restore tauning by force ama develop tor kaneba per unit area ka adu stress ko eba then strain in kaina change in configuration to the by the ratio of change in configuration to the original configuration neba aduna turna kai gumba stress ka strain gaji kanana han gani stress layer kanda strain laydura or strain layer kanda stress laydura har gadi kai khumbe ma'am yes for example rubber am layer ko sida yung rubber am layer ko rubber is suppose si kai do ba steel gi rod ne na khala je ba sigi je ko yai ko ma'am so sigi rubber je ina sumaina kai do we have the mazi deform toreba magi sangbai chang sigi chang dum sangjaba ne ba ko aduda sir na kai do we have the magi length se deform toreba now this is longitudinal deformation ko eba sis yantai ko this is known as longitudinal deformation and then ko to pa kai lay may just show to we have the for example sigi je yung ko sigi je kano yar suppose sigi pot se sigi box ida sir na sumaina force ama ko sigi surface ida force sumaina pitha banataba sumaina pikat banataba my surface ida sumaina tangential force ko eba sije circle ama da tangent hargadi magi towards the center changudana te point ama khatang khak magi circumference ta point ama khatang power sakib do tangent ko idana sumaina to tangential force hargadi sigi ida ina sumaina force am piragadi sigi suppose si box se fill up tawreba ko sigi solid se box amaneba cube amaneba now sigi da ina sumaina force am pireba adu di sigi force si kai ko tangential force ko eba se gyan tai ko isa ana pochi this is known as tangential deformation yai ko this is known as tangential deformation and then sir gida lady lay trenoina kai go stress ki ball haibra kai no ball am laibedo kaini smiley haibra kai no kangde adugi yega the noina ga sum stress ka le kan na just fine squeeze stores hana ya the fiction be have the ko adan adu the noina kunna paisal kan na fine press to my volume the pithai dana ko adu no volumetric deformation ko weba gyan dai guys ya adu no volumetric deformation ko weba yariba myam no ma ya de
Yai sir.
yai ko adu gadi as haidokre lo na ina kena to box it up anyway no problem so khara di yaram once ek ko na hapsal lage ko now sigi pochida ina si sumain torga deform to buda hauji pudi ka war ni ko si kano yaram ni ko so anyway hazik ke we have the longitudinal hand to si ko longitudinal have the lengthwise now si rubber gi mo to si steel rod ne na khala je whatever ko and then si solid amani ko now si ina sumaina stretch to matam da mangun da kay yaw ka ni masam thanda restoring force am yaroidra yarakani ko so mangun the stress yawarabne bas now sigi stress ke do we have the towards the original habidi ke do position na chana configuration the hanjanna la ineba ko aduna sir na haning is kai no ham matam da stress ka strain ga kanana han gani habdineba noi khala haro stress ka strain ga kanana hani strain layer kan the stress laidura stress layer kan the strain laidura haro
strain layer kan the stress
strain layer kan stress laidune ko very good strain na haniba stress na han ba ya deba gyan dai guys kay you know the stress is a restoring force neba now nang na kemta deform su to dana kamain to no restore to dino ba magi original configuration the layer ga di restoring force kemta layer ro ana pochi de nang na kay do we have the strain khara hana kay no to ba strain khara hana kay introduce to bam change ba strain khara introduce to ba di kay pochi deform to ba pochi deform to ra ga di strain khara introduce to ba hai dune ba body am the solid am the ko ana nang strain khara introduce to ra ga di or body am nang deform to ra ga di kamain deform to buno hai longitudinally deform to ba tangentially deform to ba volumetrically deform to ba in whatever way you want nang any solid am si deform to re ba ko au da kai lakani magi hanagi original configuration da hanjani ki pai tendency am lakane ba adugi tendency du kai kawi hanagi configuration da hanjani pai tendency da no response hanagi original configuration da hanjani pai tendency ji kai kawi anjali kai kawi saitapos kai kawi haro
elasticity.
Very good ko elasticity kawi ba elasticity habidi hanagi original configuration du da hanjani pai tendency du ne ba ko and then audagi haziki hanjaninga pagi tendency duna maram orga mangonda body do ka yarakani have the restoring force am yarakani ko so adugi restoring force per unit areas ina koina stress ko godoine so sigi stress makhal lay longitudinal stress lay tangential stress lay volumetric stress lay ko so adugi stress makhal je khoi jik tam ma je ko now first we will study longitudinal deformation and then sir kaino si plasticity si am explain trom drain hai plasticity haragadi original configuration da hanjaning da bodo adu plastic adu yamna plastic ko material ko for example nang again some plastic am ja launching to ko ma hanjaning akti na adum permanently deform oi galina adu gum do yamna plastic ko material ko plasticity kyan tai ko isa brittle ga plasticity ga kenai ko brittle lamna tatkan ba kaigan ba adu gum na kano ko brittle ko anyway now let's do longitudinal deformation ka longitudinal deformation. Now, longitudinal deformation, let's say I have a rod like this. Let's say sumai lereng khala jebo ko rod ama. Now, sigi rod si aina further ke do we have the chingthu ebo ko. Sing thokpa matam da sigi same rod si aina chingthokpa matam da massage da kai lakani have da let's say sumai chingthokpa ni maji ke do kani have da okay PNB agadra yam okay sisina kitang ni pikpa maleka saw manabra saw di sapu manay ni saw chap manabdi ade duna amak thing we are draw punne the logo to yeah anyway I'll draw once again ka yung kina tawon male ka kitang pictpl la dum ne ka so si na ka pe da na ka now hojik kai da we have matam da sigi hanagi road se length kai da we have this, let's say this road is of length L ka aduga akon bagisina kai ko we have the margin L plus delta L ne khalase ba ko aina kai do we have the my hanagi length original length L khak sangjaram mane ba audaidu da aina chingthok daidi kai do re have the L plus delta L sange ba ko auna mangon da kai lakani have the restoring force am lakani ba gyan tai ko abdi sigi sida aina jiksi posis hang id kai do ba som side ta chingthoi ne ba and then si ju kai do we som da chingthoi ba ko no sir ani sang mana di kai ginon khalagadi sangbudi managadabni kom haidi again it hardly matters adu de am kana matter budi taude ka so si sumai le aina chingthoi ni ko se na aina both sides ching thok ko so auda kedora I ha matam da mangonda stress am develop tor kani ko adugi stress to have the restoring force per unit area aitare ko the F by A is directly proportional to delta L by L ne ko now this F sikino this is restoring force ne restoring force now restoring force ikadom da so the restoring force will act here ko and magic in a kamai x ge have da sumaine yek tam ko wait a second restoring force si sumaine legaduni ka and then maji som site legaduni and maji si da leini and then maji som site legaduni restoring force ka and restoring force kai da leini have the si ke da surface area si leini now sigi surface area ji khatang lai di sida khatang na te swai de ju dum lai pi dagi swai de ju dum lai pi ko wherever haidi dum mafam phanam haidi mafam khuding makta haidi hanagi original configuration dagi endoki ba mafam gai da loina mak stress lai ni ba gyan dai ta de tai ko respond khaga to ro ma'am tabro tai ko okay fine so do we have the now sigi is in a kind of the area of cross section this is area of cross section and then what is delta L haragadi change in length now noina mun observe to buta haragadi sir na mamang ida kai have the strain has the ratio of change in configuration now sigi configuration se longitudinal da length harakaduni ba tangential da area harakaduni ba volumetric da na asida su dum surface area harakani ba ko so mai magi matang ne now sidana change in length hani L jina kaino L jina original length original configuration gi mota original length na la ni ba ko aduna di kada we have the C proportionality constant to F by A is equal to arga Y delta L by L and la ni ba ko now what is Y harga Y is known as the Young's modulus ko and Y is the kind of general it is kada wa modulus of kai haidina now Young's modulus is one of the three moduli of elasticity neba elasticity ki modulus ahum leiba Young's modulus haibama shear modulus haibama bulk modulus haibama ko so adumaina so we have this formula yarbo me amsi kise
Why, sir?
yare ko okay aina makhon ji am tappi ji sound later thambra tinge oh makhon ji taptai later thambra ti brightness kitang like yare ba yare ko all right fine yare ko so that's longitudinal deformation mathangda kaidoba mathangda tangential deformation ang tawrsi ko 사실 우유인 로진 팜이 막 가도 box 안 내고 가도 팜을 많이 트레이닝 then let's do tangential deformation ka now tangential deformation the let's say I have a box or something like this. Sumai na layer may box sama. Then my CC straight and so anyway, sumai na layer may box it. Now, any hezike that we have the mangunda force na pire ko my surface the force and pire. Again, force pire matung hadi hana pire hadi maji ke do deform tawre baina ko. Maji deform to matam da kai mawong da lakani ha matam da somewhat sumai lakani. And then see go hando kata sumai lani. And then kaido we see the ini sibu sa like then amazida sumai chakrani and sumai chakrani and sumai chalani into chumbra. Sidagi si surface si chalera ka aduga sida soire ka adati sumai chalani ka and then maji sumai na lakadani aduga sumai chakadani aposi ka deform toragadi sumai deform lakani ka deformations so makagi si tiling badi yade duna makagi si ling yade ka mathaki si tagi tang tawgadani so sumai chalani hatare ka sumai toraga posi deform toraneba. Now, deform to matamda kai lakani ha matamda pochida masa mathanda kai develop torakani restoring force ama develop torakani hanagi original position da hanjanna ba haitare ka. Now, sigi kayamu degree of deformation je koina kamaine lawzi have the let's say maji sidaina si pawuze let's say this is kaidoba this is let's say this is x and lower gap koina and then magi kaidoba sigi distance na kai height and lower gap ko then si box and let's say this is h adu di sigi angle si theta zine deform to is chamanana som side to angle theta deform to ni asom do theta to ni loinamak theta to ni bu ko CC tangential deformation or shearing and a C is the kailakani have let's say F by A is directly proportional to X by H never ko. Now adu ergadi kai lay hamatamda or you may say F by A C again where is F have this is F ko. FC asom side the doing restoring force and then areas in a CG surface CG ke the tangential areas in where the force X kyan taita de ma'am tai ko ma'am taribo tari ko okay so adu ibitaraga this kai lay hai matamda F by A is equal to haraga ina again shear modulus ki symbol zika ita sizinabra I'm not sure ka ita adum sinerge ka ita haraga kai x by h na ka this is my known this is known as shear modulus noina sigi kai no ha matamda kuina sigi pot se ko x by h sometimes tan theta sizina u thing na ni ka tan theta di kai no opposite by kari adjacent ni dana ka so sometimes you may find or you may find F by A is equal to eta tan theta na ka sumain thing na bzu dum yaw ni ka now tan theta is equal to tan theta is equal to x by h ne ka sisim khangjalo yarbo ma'am
Yes, sir.
ka okay fine so see that I'm bright and mid chicken tor yeah okay fine yeah ka so this is known as tangential deformation how they last mathang the volumetric deformation and like ka dung torsi volumetric deformation ka now let's say volumetric deformation see no ina kidoba let's say ka I have a gas balloon ka balloon nam le ka let's say how yes
previous slide untuk
previous slide ta yeah Yarbo?
Yeah, sir.
Yarika. Okay, fine. So, Kenoniko, sir, nobody Tarakaniko. So, copy you in a Shikize. Was ungang leaves it. Anyway, now volumetric deformation towards the car. Volumetric deformation, let's say, I assume a top put a lower CI. Let's say you have a spare or you have a balloon. Mazi, it will have squeeze toraga, shigi shape sida. Squeeze toraga, shape si, undergrave. So, mine, shigi shape is like grave. I do really have them with the restoring force. I'm not push to a poach. Again, that guy is a restoring force. Compressed over nana hidi compressed over or nana expand over gana muka hana original configuration hanjana monar kane aduna kedo we have the f by a is directly proportional to kaino have the delta v ka now sida kedo we have the delta v y v ne ba sigi sida di aina kemta keno term dre ka again this is what is x haragadi x is the kedo wa distance ka displace haitare ka and then what is h the h is the the distance between the two ka between the two opposite sides the hairs you have h ka aduga sigi sidati what is delta v the delta v z kaino have the delta v is final volume minus kedowa always akwina kedo we have matamda delta zilo matamda initial ga final ga difference over the final the initial khaidokani buko so final volume minus kaino initial volume never so final volume na p abani na negative from tholakani ba gyan dai ko vf minus bic all negative id adu negative ni adu negative to koina counter tona ba minus ama the half kani buko so na f by a is equal to harga bulk modulus is sometimes k over sometimes b over ko ib sin harga so minus b harga delta v by v or neba now sigi v z canonico volume niko velocity gana teko amuk canone na khalem now sigi si I can change this f by a as p ko pressure and high v now sir ngasai gi pressure high draga housing na pressure high ji kai gino na housing na pressure high by maram di kai na see surface area the all throughout the surface area da ne ko mana keno to bodu si force lei ga du si auna akoina pressure is the loosely pressure is force per unit area or force upon area or force by area ado heta yadeba akoina chumna haigadi pressure ki definition is force upon or force by surface area surface pangadam ne nang surface to pandragadi kedo we have the adu pressure ne have ya the normal force upon surface area or simply force upon surface area haigada ne force by area it can be stress ka anak ID aduna stress the pressure is stress makalam ni force by area the stress ni but force by area to the kayumba surface area or the adu dubu pressure ka rokadanya ba du stress to gyan taita de me tabra like okay fine so kuina we have discussed the three types of deformation ka so koi sidagi hogi bani ko ngasi ta aduna yedum yengo thengna yarpagay recorded session da yengo ka do endere now volumetric deformation there ka matangda we will do stress strain curve in torsion Young's modulus ki ka elasticity ka Hooke's law torsi and then stress strain curve ka Hooke's law na haisi kemna te ka Hooke's law na haisi stress is directly proportional to strain and then we have the stress is equal to some proportionality constant times strain la ni buka aduga Okay, yare ka rate no tawjira khanbadai wani. Now, what is this K? This K is known as the modulus of elasticity. Modulus of elasticity. This is known as Hooke's law. Yam live in the car when already already told Hooke's law is Hana Taxalam as a for them. Sida policy Hooke's law atani ka kaina. So, sida takum yaw trade and sida Hana ka. Yeah. Natraga Hooke's law do na mamang the Purak Panadi Favaka. 1 second. I'll just bring the Hooke's law here. So, kung hanasi tawre matang the Hooke's law tawre ka, stress is directly proportional to strain. So, stress is equal to K times of strain, and K is known as modulus of elasticity ka. So, the rest now longitudinal deformation tawre matang the tangential deformation or shearing zo hai ko sigisa. Na okay, ay sigisi maming piramdre ka. Sisi kay kawi, this is known as shear modulus. And then sida in a B is maming piramdre ka. B is known as bulk modulus. Bulk modulus or modulus of rigidity so high kamaze. Modulus of rigidity. And then we know that tongan ba to pa makhangjan ba na kayo na the B is equal to 1 by C where C is known as compressibility. Compressibility. Now compressibility ka bulk modulus kasi amana may reciprocal wave ko. Now bulk modulus sabzi kayo have da bulk modulus sauri ke port ama zinang na magi volume zi deform to waga doing ever. Haziki port sinang na squeeze to wangam wave one ever my bulk modulus am sauri ke my volume zi change to one ever. Nang panam compressed or goes my volume zi picture lo yaro bulk modulus am sauri do tiko. And C is in a compressibility hamne compressibility agadi yam line compressed over yabudu compressible compressibility wang ba ka weva. Auna bulk modulus ka compressibility ka za amana amagi reciprocal chat na yeba. Gyan tay ta de ma'am tabra sida based of question ama hangra bane ba ko adu in sir sisi. Yeah ka. Okay, fine. Now let's do stress strain curve ka. Now stress strain curve sir na noi already high the high graph din ko. Recorded session yeng ba kang bu ko noi judum khangam ni ko. Kay do ako na graph ama curve ay graph ama maming thon no matam da kay na dum hana tholi. Habidi kay ni y vertical axis and horizontal axis sida kay hadi x ka y is the y na hanbra x na hanbra x na halika to handi y na dum hale stress strain curve habisida stress ina y axis ta legi duni yantai ka stress ina y axis ta leni and strains ina kay do ba strains ina x axis ta leni always y axis na dum han gada ba maming thon bada yantai ta de stress and this is strain. Strains from the land, stressness from the land. Yare ko? No in a class 10 the keno tamakpada ohms law tamakpada kamain tamake VI graph ka hydro. IV graph the high deva. VI graph hydro. Hydro bro.
Hi, sir.
High ko. From the V lane, from the I lane, duga magi kedoba. Sigi constant to kedoba B by delta I constant to resistance kind of gadainga tamakto B is equal to IR kai torga ohms law na ka. So anyway, always y axis na hana kuina kina taweba ka. Now sisi da kuina kedo we have da port ama zene deform to matam da ka. Kedo ni have the magi stress C henga tay matung ina strain dum henga lakani. So yeah, I use a red line ka. So let's say sumain le and color Z. And then kedo we have the sumaina amazi sumaina paida bahorani ka. Paida bahorani. Then awdagi sum paida rakpaduna sumain chatkre duka sumain chatlaga sida my tatkrani ko. This is breaking point. Okay, fine. Yare ko. So, okay. I do good dotted line. I'm going to get dotted line. See, don't worry, ka. Sir, na ji kena torokani explain torokani ka. Adu dum gyan tarakani na. Kai knows it. Sir, to kai knows it ka. Gyan tarakani. So something like this there. And then, all right, ka. Now see the kitang chathabana pabra, chakatpana pabra. I have no idea. No CR, right? 1 second. Season pabra. Yes, season kitang pabra ka. Ako na take point ka. Anyway, fine. Now this is the O ka. Origin, and then let's say this point is A, and let's say this point is B ka. Let's say this point is C, and let's say this point is Kedova D. Now, what is A? A is known as the proportional limit. A is known as the proportional limit. And what is B? B, sorry. Okay, B is known as the elastic limit. B they here and the have name B kitang chakat ka. Elastic limit kitang chakat ke swai de thang ka B. And C is would the any thumbing pa thumb ka. B matung the word yare. Elastic limit layer ka B. And then C is in a kind of C is in a yield point ka we. And what is D? D is na fracture point ko. Fracture point. So now, we have I have a string. I have a, let's say, whatever. I want the wire layer. Preferably, see rubber plastic permanent deform marine steel we have the highly steel highly elastic elastic plastic steel no response.
Plastic.
Elastic steel na sir steel the marine elastic elastic have the marine elastic have the restoring force hanagi original configuration do the elastic have the aduna steel we have the magic hanagi original configuration the hanjaning have the construction yum achova haidi kaidoba haidi kene azikan noigi kari kaino lomda haitare ko kai haisige zenim satpai lambi do ko noigi kaino dagi chekon lomdagi chalaga adugi lambi duda zenim staba lambi haidura khangdene adugi nate zenim staba nate ko nongoi bungi lanthoga somsai ki do hoi chekon gi lambi aga adugi mamangi lambi duda construction tawbagi moi crane acho acho leibne adain tawdno or any noi thawalambi saring ai matabna noina thingnaram yai ka highway sabda or whatever acho acho construction project sing da nung acho acho block cement ki block acho acho do thangat pada kai sijine rubber band sinabra rubber band thangat pra rubber band acho nauri marugi rubber band simung thabam chang adain to thangat pra thangate ko kai sijine ha no response. Khangdi still season still gi thori ni season still je marai tar still gi thori thabane season je kyan tabra rubber season ri tat krani but long tat krani ba acho my construction kai have the steel je kai we have the steel je restoring force am chawe ba steel je pak na su tat kan de ba ko tat kan da badan nat na kai da we have the nang na load achouze thangalakpa matamda ko tons and tons ni ko samu muglunga doine yanda right auna or whatever aduki matik haidi some 10 kg 100 kg gi wana teba cho thangalaka doine auna kedo we have da adugumba concrete haidi hairiga saba cho do koina thangatpa matamda still do khara stretch toram niba auna khara stretch put already deformation leire strain leire ba stretch to wise ma deform to rabane auna strain leire strain leire ke dor kani restoring force am create to kani ai masa mathan restoring force ma develop to kani ba now adugi restoring force per unit area do stress ko ba so still je ke do we have da still the tholak per restoring force aduki matik chaw ba and by restoring force have the kind of that the tendency of a solid to regain its original configuration je si jibu kai koi elasticity ko idana elastic aduna still je ke do we have the elastic yam oiba haiba highly elastic haiba still is said to be highly elastic, which means still has a very high tendency to regain its original configuration. And akoina sisi further translate tawraga still developed over restoring force yam chawi or stress yam chawi na dan higher yai ko aduna let's say kedo we have the ainus for example sisi still road ne ngatan khalo ko ai sisi kedo we si sum ching thoige ai khut the pressure ji yaw ba hore ba man chingjaning ba tendency mi yaw re ba sum swine sum sum ching thoige my tendency sum original configuration da hanjaning bagi my restoring force sum kankhale ba ko now aina strain ji sum kan katpa matam da ko myam yeng ko sida aina strain ji si bo lo matam my stress is si ore aina strain ji si bo lo matam da magi stress si la ba aina strain ji si bo ba to matam da my stress is si la ba aina strain si bo to matam da my stress is si la ba aina strain ji si bo pi matam da my stress is si la ba ko now si ke do we have straight line ta dra sa so this is directly proportional or straight line ta ba so CCB kai kawi proportional limit ko eba having nang strain hengala yu chang do aduga proportion chana na stress odum hengalakpa restoring forces sum kangalakani nang strain sum kangat puguding ko adu du kai kawi have the proportional limit ko eba gyan taita de
Sai.
response tai ko
Sai sir.
okay so adu du proportional limit ko now proportional limit has suppose let's say c is the proportional limit ai sidai hina further ching tareba further ching da matam the stress su hen di hengaleba do hana hengalak pa chang do adwain di hengalak teba ai yam hengalak pam thokune khare dang hengaleba auna for example aina sidagi aina ke further sum ching thoku matam da di ke do hana hengalak pa chang du da hengat kya ga di ma si bo hengalak kadam neba asi yaudreba si dang hengaleba adu di ke do have the stress hengalak pa kha wat leba aduna CC proportional limit tagi wang the chat crave ko but kaido we have the maru or is kaino have the aina zik strain zik lok thok matam da have the aina kaido war string force lok thok aina sorry aina deformation ja kaido we the puzzle tam lok thok matam the restoring force no original configuration the chap chana hanjan ning ba budi like duni but chap chana hanjan gi bado adu bo hanjan lagadi kaido we have the haziki maximum strain and stress ki adugi point to adu du kai ko have the elastic limit ko eba elastic limit tagi aina hen na chingthokragadi ma do amuha na hane original configuration da hanjala roiba elastic limit ki concept se elastic limit ki paidi kai what's the idea behind elastic limit elastic limit is kedoba is a point ko which defines the kedoba maximum elastic strength of a material neba auna elastic limit or elastic point si hendokna nang deform tawragadi poche permanently deform tawgrane amuk hana hane original configuration da hanjalo have yaro aina sigi rubber ji ke do ya tap tai ching thoragadi kaidone marine adum permanently marine chakkrani ko elastic adu rubber gi wari na steel da jungaire tap tai ching thoragadi elastic limit haiba point to adu dai hena ching thoragadi elastic limit haine aduna elasticity have the tendency to regain its original configuration adugi limit to hendo omni na kedorane elastic limit hendo dia permanent state ana permanently deform to ni ko ni nikhil yaribo nikhil tabra nikhil ji ta da male mute chu tam de sarna mute thamage kanang ji ta da male anyway fine so ke do we have the b is na kaino elastic limit ka adagi b dagi hendo kradi yield point ko ne ba elastic limit tagi hendo gadi nang na ke do we have the nangna strain se nangna jar launa chingthok ma ta mai restoring force pak na hengal o ya roi ba ko adum ai chingthok da lai ra ni ba nangna ngasai gi yield point gi mamang pho budi nang chingthok da wa ni ba kai no di elastic limit phowa haigera whatever ke do we have da magi stress my stress so dum hengal le nang strain hengal li ko adubu elastic limit tagi beyond nang na hena chingthoki ba tar ga di magi stress hengal ga su yam chang do hande ne hengal le ba hendi hengal ka du ni but yam khaidi nga sai hengal pom thopu da daina ina strain de hengal asuk hengal pom tam da stress so asuk hengal ka dam ni have do adudi oidre ba ko awna ching with the lie re adu yield point ko ne ba ko so jar long chala ni ba awde ke do ni have the sidagi ina curve si kitang tekal isi kai gino ha matam da sigi curve sida kitang tekal isi kai gino ha matam da mazi da stress si talam da gi khangen hengat pa chang ama lei ni ba ko poche talam da gi stress ai restaurant force kitang kankala ko pak launa kankala ga tat ki doine ba ko aduna adugi stress si kitang haigat lam gani adi kitang hengalakani aduga d haiba point fracture point si da tat khrani ba ji string je gyan tai ta te tabra me am loine ma
Tai,
Tai
sir.
sir.
tai ko so sigi chang se si si bu kai ko we have this is known as permanent set ko eba permanently set tawgreba permanent set habdi magi length hana let's say 10 meters hangjaram ba do 10.02 meters hangani ba permanently 0.02 gi meters ya habdi let's say 2 centimeters ya permanently set tawsan grabne adum yauzer ne ba kaigino di aina maji elastic limit tagi hena kanna chingthore ba ana maji elastic limit paudi aina chingthoga so adum hanjangi ne ba 10 meter dam hanjangi ne ba but elastic limit hena chingthoram ni na permanently set tawsan grani mai configuration do ahong ba ma lani ko ana adudu permanent set ko ba ko gyan tai ta disi stress strain curve se phajana gyan tarba myam loina ma
Tai sir.
tare ko noina khanga da babu a ga b ga sini koi maru se b bu hendo ga di yield point si b gi nakna na laigera lapna na laigera b gi mathang da lakadam ni yield point se ko and fracture point na last lakadam ni a sina proportional limit ha ga di straight line oigadam ni b sina kai no elastic limit ha ga di straight line oira traga su khara phaira ni ko oira aroi ha tai ko straight line oira khara phaira ni khara phaira pa hobaga elastic limit laiduni elastic limit tagi yong hena chingthoga di permanent set form torni ko aduduna yield point see no anywhere long below vi and then mathang the fracture point ko now yield point should come after elastic limit ko elastic limit te khacha thoga dam yar so this is the stress strain curve now last topic of this mechanical properties of solid ki quite last oiba iroi loiba topic se kaino habda kaidoba magi maming ji ko elastic energy habra elastic potential energy ka domaina or potential energy stored in a stretch string ka potential energy in hierarchy potential energy ka stored in a stretch string ka sizim torsi now sisina kaino habda nasai gi kedoba rodam lere let's say rodam lere ko maji ina chingthwe chingthokuma tamda maji fiction grani ka I picture ma like fiction grani so sumain chingthokatuni ba aduda kedorakani have the mangonda or CCA logthoga saigi eno doing to one for ni ko sumain torga dot tor sibu singtwe ko singtwe now singthoku matam jida mangonda kai lakani have the mangonda stress na maram orga mangonda potential energy am yauni ba so adugi potential energy yeng se ba now queen potential energy delta u is equal to negative of work done which is equal to minus arga f dot dx ka now f dot dx kaido we have the let's say dx in the machama loge ka let's say this is dx and restoring force f sina from the opposite side ni dx na from side ni ko ina increase over there now f learning ko now what is f haragadi aina we know f is equal to aina kai khang have f say y a haraga kai no have the ya haraga kai x by l ne ko aduna we have the y a x by l lerni ka. So aduna lerni restoring force t. Okay, fine ka. Then this is my f ka, and then c dx lerni, and then c ki ani opposite oina nina sidai tholakpa negative to ka sidai tholakpa negative to ka negative si mangrani ka. So sumai lerni. And then mazi we have the this is 0 to 0 to L ka kai x ka x I see delta x yare da ka equation adum 0 to x and horen adum haige ka x po to ya. So cc kai lerni have the yare ka kai no person e treasure. So zik y si constant ni area of cross section je koi asing the area of cross section je constant oi de ba ko noi Poisson's ratio kind of tamakani ba the area of cross section kitang di pathrakani ba kai lengthwise de helakpani na ko, but adu khoina adu neglect to thoga dum constant en lore lg constant en lore adu di sida ine kaidoba x to integrate to taragadi x square by 2 tar ne yan tai ko isa. So adwan got x squared by 2, and this is, let's say kai den kai phone have da aina kayam stretch story no have da do the depend or so let's say this is kaidoba delta l harga 0 to delta l and harga ko delta l po aduna this is harga y a half harga ko y a delta l by l. So this is kaidoba x squared by 2 there ko, so delta l whole square le enable. Yeah, de ma'am. Yeah, bro, sige sir. Yari bo? Yari ko. So 1 second ko ay atopa kitang form phajaba form la atopa da kena torake ko deduce torake. So sida yari bo yc kaino sida yari bo yc Young's modulus ko weba ko. So this is half, and this is the what change in potential energy in a domain has yare. Yare ko. Now aina zik kaidozige ha matam da, can I write like this? Half y ka kai kitang kano chale direct chale ke half y le na ka aduga a ha na ka aduga l ha na ka aduga delta l by l whole square. Si abra yung ni sida mamang is the kai do single l ne bale sai na aduda l square to ni na odi makha da l ma hapak pai ne square to ya je odi makha da hapadi mathak ta so hapta ba or mathak ta hapadi makha da so hapta ba ani mak sida no na khaning mong khallo. So a into l di kind of volume ne ba on a half ka Young's modulus a into l di kind of volume, then v has or volume, then kedoba strain 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 square. So sumaina higher CI ka potential energy, or what you can say is the ka anyway. Now CC ainam kai have the half iron y iron duga y amaga strain amaga di kai doni have the stress tar stress into harga strain into harga kai have the volume. Yeah, bra. Sorry, Young's modulus into kaidoba wait y into kaidoba strain never got y into strain say kaino never got aduna y is yaura roy and the mukti half into harga stress into strain into volume. Yeah, bra me am sikize. Yeah de.
Yeah.
Yeah ko. Sir, sigi stress kama yaura ina sigi y siga strain amaga paraga stress on granny strain ama lemorani ire volume lemore sil ire half silere ko. So sigi formula ji ahum maksi noi khangadamni ko makhagi sigi formula si dasu sizu khangadamni, and then sigi last ki formula sa sizu khangadamne ba ko. Now sisi da noi da kedo we have da noi gi NEET ki exam gi oina di takpudi tasing budi loire ko sidai hena noina question solve to bagi oina di solids mechanical properties of solids sida pungoi lore tak sidai taninga yaudre ko so kai gyan ta da yawi adu sir na kaino kitang henjana budi khara talakhini ko but ajik ngasi gi class sida kai gyan ta da yawi ma'am hainaro Shivani
potential
haro
potential set
kai heba
potential set
potential set have nati permanent set have ni
adu permanent set ki da dotted line am chatle
oh okay dotted line ji kamai to bono ko okay sir harake ko sigi ji kaino have da nangna azigi solid se sum deform to matam da ko ngasai gi ke the point o to a se o is in original configuration ke straight stroke diri ko something to restoring force na adum hanjan gi bai ta original hai ek thado ko hanjan gi ne di restoring force sum hengale ko aina sigi ke do have the something to restoring force to sum kankale strain hengale restoring force kankale strain hengale restoring force kankale strain hengale restoring force kankale ko but at a certain point have the ngasai proportional limit to lan to elastic limit yore ji elastic limit tai hen ek lan thok yu matam da ke dorani abda maji hanjanma matam da ne hanagi original configuration da hanjalo yara roi ko kitang deform tawne habdi marin ghar chalaga to hanadi khar telam mane sije aina di tap tai ching thobu de ke dore marin ghar chatleba aduna kai do we have da ngasai gi sigi pachi da hanjan ba taragadi original configuration da dum hanjan duine ba but sumaina hanjan da bida sidagi oina hanjan gi ba taragadi ke do we have da ngasai strain khare de dum yar leiradro ngasai horokpa matam da di kai do we have the point o sida di strain amta yawsa de dana sa strain yawde ba ma je hadi deformation leite ba strain have the deformation ne ba strain have the strain change in configuration by original configuration ne ba now change in configuration the zero oiramnina kai do we change in configuration zero oiramne original yen bu su dum zero divided by something is zero nina ma je zero dum le ne ba strain je but aina kai gum potsi b as ke no b is the elastic limit hena chingthora ga di ma je thadokpa matam da magi strain do zero oira roi original configuration da hanjandre habne zero oida bai ko kai doin halle sidoin hanjale aidi sum hala ga sidoin tagre habdi permanently maji deformation khara or strain khara leire ba permanent set tausan greba sijibu permanent set ko adugini sarna dotted line laga sida khara henduiji kai yunabda sigi chang ji di maje permanently deform tawrabane original da hanjandre strain khara di dum yaw le ne gyan dai ta de tare ko okay fine so kenoji red music keno hai se red music kana hoidina ming kai koi
hai
saila hoidira okay ming wena happy adro saila okay kaino di red music nikhil ju redmi na to heta changi aduna sir na ngasai ge ang nikhil ne na khalui ne ba ko kavita di ang tat kramala internet se anyway ma ngasai internet kanu mai ta mala anyway fine ko atai di loin kyan ta hobra Christina Anjali Kaninglu Shivani Lakshmi Seta boss
Tahu sir.
Tahu sir.
awi ko loin ai ko okay so adu ergadi makha to boina ko bi kya tare we have okay 9 10 katang sitang ai ko matang da keno haige ko comparison khadi to godam ne noi textbook to NCERT ki textbook tagi compare to godam ni so okay adu to bring this sir keno khara pige ko some point khara hai tare ko kuine kai khangadam no have the Young's modulus se it is greater than a bulk modulus and this both ko are much greater than shear modulus yai ko si jima khangjalo ba aduna kaido we have the Young's modulus sauri kaido dina na pot am ching thok wa du ne ba kai no restaurant for saur ka du ne ba adagi bulk modulus sauri kaido dina na compress to wa du ne ba and shear modulus sauri kaido dina na pot twist to wa ne ba gyan tai ko isa aduna body amagi magi same body amagi Young's modulus ka bulk modulus ka kaido shear modulus ka kanan khoi chaw Young's modulus tan khoi chaw kanano noise tholaiza chaila okay sir mute torke ka so kaido we have the body amagi ne Young's modulus ka bulk modulus ka shear modulus compared to the Young's modulus na adum barabar chaw hen gani bo khaji kara kana te yam hin ni ka so 1 second maybe kaido wa NCRT the yauba kara lauzi ka data kara lauzi so we are with the pending apakta class 11 physics ka book 1 book 2 yaure ka quiz 1 second comment mechanical properties of solids elastic moduli ka yengo mem sida ka Young's moduli and yield strengths of some materials and high ka so we'll copy this diagram yield strength is not much required for substance Young's modulus in pounds I do not let's say see copy target and magi corresponding Young's modulus ke copy target there you go see this my name ni buka aluminium then mathang the ultimate strength hai this ngasai gi do tat ka da jaga do ko breaking point ke ka do ni so that's there is no aduga mathang the to si ni ngasai sar ta ki do ko and shear modulus ang ka si mo to si shear modulus din mai ke na si zero ko mo ni ko zero and then mathang the bulk modulus ang yin si ka bulk modulus yin tong chaw wera now do orbital gadi in zik si kitang some put worge channel ka okay channel ka then si kitang pl lage ka okay noi ding sai ding screen share tau tri ko male tawra ka this thing and this one there yeah smine tham lage ka yarba yeah si kitang chaw lage at least so man ko diyan kitang ka chaw yeah ka okay fine now I will use the symbol Z kaidowa Z yun sizinage ka Z sumai lere now khwaide kan bapot oina yengse steel Z yengse ko steel gi Young's modulus se kya namya 200 eva 200 into 10 to the power 9 newton per meter square yauna 10 to the power 9 newton eva kaiba yari ka okay fine mathang da magi shear modulus yung yengse ko steel gi shear modulus se kaino only kaidowa 84 neva 84 into 10 to the power 9 ko and then magi bulk modulus ang yung si ko still gi bulk modulus still sila 160 now haining ipo se kaino ha matam da nangonda suppose still gi rod ampere sigi still rod cha nang na maina chingthok pada wani ba robi wani ba ko adu nang na sigi still gi rod si nang na sigi still gi rod si nang na bend tawbada nadi chingthok pada budi bend tawna khara hena line sorry bend tawai kaido compressed over na hena line ni ko chingthok pa budi and then karina khwaidai line ni habda twist tawne line kon bana thek pana hena line ni gyan dai ta te tai ko mem yari ba
Yari.
yari aduna kedo ya akhoi gi kedo ya human gi bone noina heng ko noina ji noin tha do exam ni NEET natra medical professional or academic physician or academic ji ko aduna akhoi gi khwaidai gi kedo ba largest bone ji kaino
Femur.
femur very good very good very good femur bones ke do we have the femur bones na koi gi body weight sa whole day support or line ne chat pa matam da ko especially kuin walk to or chat pa di hip pa le ga body femur na support udre but akoin lep ga layer ga for example let's say sergi weight see let's say 77 in color 77 kg or 80 kg mana dum femurs in a femur ani support or line whole body gi weight koi masagi ngasai femur gi weight ka adi khara kathagra whatever majority of the weight the femur na support now femur ji ke we have matam da koine let's say kai id sir di am kan hai di hai tre ko no gi bone num yek pa da let's say sigi ji ke da wa sigi ji femur du ne khala je ko and then mai si da ke da wa kai ka noi term kha lei bani ne kai si je ke no hai da na sumaina sigi term jira phalanges sabra something like that I you call greco I am having take out see biology so anyway okay we have the femurs the okay we have the femurs always magi longitudinally magi compressed over tawrelai ne force mai akoi body gi weight na ko aduna okay we have the femur isu magi young's modulus am lai ne ba then aina sigi same femurs let's say aina aiga weight manaba mi maina thangal leba natragana aina kedoba I suppose let's say powerlifting the powerlifting to kangbu do moina kedo 100 kg ga thangatna 200 kg ga thangal idana adu thangat pa matam da thangalaga straight lepen khala jeba femur ji kitang do ju compress to uni ba ko ado kedo we have the femur gi young's modulus se adu da ne ba haidi my femur ji young's modulus am chawine kai ji mana weight kyam pubangam ge do my masagi amna kan dam na amma oigre ko kan ba chap mana femur so lai te ki do ne ba ko femur kal li ke dong ne have da weight me am pungam de ne ba adu duna young's modulus lom da chatla ne now sigi same femur ji nang khong ji ke do we have the kai no ma thangala thamme ba so si khong ni no ko so lep te ni da so thangale ba sigi thangala ga si mathak si da kai gumba 200 kg gi pot ama thammaga si femur ji te ki ji ya or 500 kg samu omna kakala ga di samu omna kakala makong so thamma si femur ji ke do ni te ki ni ba adu same samu duna sumaina si da torko or again samu de koi crush pudi to ni ko sum just an example ne ba po che to de ko ne na line ni ba ko maji compress magi ke do ba my leng tension and babudi to de ko ne live gyan dai ta de tai ko te khini ba aduna bone adune no heng ke do yevda or ke do ba orthopedic sabra adwaina adu bidu da laga di du line laga di sigi young's modulus of femur ka audagi ke do again femur gi my density then magi ke do composition da adu da calcium asuka da adu whatever adu what pe matungina magi young's modulus da 100 or shear modulus da 200 and adwain to tamaka du ne ko so duna physics ang kane du matam da ko so always bear this in mind keep it in mind that Young's modulus is the greatest for any material and then kedawa mathangda bulk modulus is also very huge in magnitude as compared to shear modulus yam pa ko auna noida aina suppose chayama pireba chayam piraga si chayje deform to haragadi khoide live di kaina to dekpa adu kaina shear modulus ne bana si naida pot twist or to deka do neba that's shear modulus auna shear modulus na kwai shon baina yam line deform to ge hagadi to deka ne ba hadi shear ma noina chwan ching thoku matam da chai do kai samta yam wa ne no ki su passing thoku ngam moi ko kaino di chai do ki su young's modulus yam chaw ne ba as compared to shear modulus ko gyan tabra ta dabra yari ba ma'am
Yari, sir.
yari ka okay fine audagi one atopa example amaga pige noina kaigumba noigi akoibada no yum sabagumba thengnaragadi yum sa matam sida ko pillar na sumaina pillar na keno le ni ko pillar he ni now pillar gi mathak sida noina sumain tawraga sumaina ama kedoba beam mana ko beam gaudan sisa sumaina ma keno tawbra thengnabra thing ko beam lakadui pillar ko re si ko this is the pillar and si beam ne now beam ji da noi na yot hap thing na bu combine thing na ne have da si da yot ama yar ni ko sumai sang chakrani and then si four corners si da yot si yar ni bu ko four corners si da yot si yar ni sumai chatlani bu ko now aduga kai da we have the makha da ju yot se sumai na hap ne bu ko mathak ta ju yot se hap ne ba adu si nakan da di hap te ba sir na haining ji gyan tabra habdi up ka down ga the yot se sumaina four corners le ani dana let's say sigi four sumaina sigi four corners le ani ba now sigi four corners si the yot se si the half ka do ne ba ubu da bra si the yot hapani si dam hapani now yot se atai ne mathak ta jo hap ka ne yot se and then makha da jo hap ka ne ba tom side to the half way ba sir gi si di khara rectangle shape ta chale square gi shape ta la ga ne hena faja ga do ne sir na haining ji gyan tabra ta da bra taiko habidi koine yot hapa matam da ai keno thi ne rectangle shape let's say she's a beam ji keno ne ba cross section ne ba beam ji sumai sang lei ga do ne ba sumai sang lei de patlam ko thala noi the face to re ba si cross section ne ba now kai dong ne have the yot hapa matam da ko beam ji da yot hapa matam da si four corner si yaur ga mathak ta yaung ne ba mayai da ama chat pe ai ani chat pe ai makha da so ama chat pe ani chat pe but somgi yet ka oige se sida di ambu chat loy yot kem hapte ba mathak ka makha ga da khatang hape ba si kai gino khang bra ba
khang de sir
khang de ba ko adu ne ba sir na tak ningi ji ko audagi mathang da khwin kai da we have the sumain lei ko kai lei sigi shape ji kai no very good this shape is known as I causes angang mo sa da hangwei type to ko si I ni ko si ja I beam go ya si na gyanta rise this is known as I beam now I beam si kai da we have the construction kai heba noise line kanano mo wangang male kai heba amtang ngai ro okay fine yare ko so sir haining is kai na this is known as kai I beam and I beam gi ko idea ji kai no ha matam da ne aina sigi ne I beam ji sa matam da pot amaji suppose let's say sumaina sa da bi aina pot am sumai sa re kala je sumain chaw am sa re thong am sa matam pra si na thong point a ga point b gi samna do ne ba ko point a ga point b gi samna da aina pura concrete sman box amoy ne hai re ba adu di kai dora kani habda khwai dagi hena stretch to go do ji karam mano ha sigi mathaki surface siga sigi makhagi surface siga ne ba si makhagi surface siga si ani ji ne ba khwai dena stretch to do ji gyan dai ta de pot amaji kai no di sigi mathak sida gari chalakani truck chalakani car chalakani mi chalakani whatever au dai magi masagi weight to no sum lum darakani una sigi mathaki surface ka makhagi surface siga na kai yumba moini si stretch to haiba yadraga di pot se adum strong oina leidune ba deform tawroidune ba moini jina kayum stretch tawra kanda ne posine teklakpa audai thongji kedoba kondarakpa kaina ga lakaduji ana mathakka makhaga gi surface ani jine ba khwaidagi maximum oiba stress leigaduji gyan taita de taiko aduna di kedo we have the engineer kanguna civil engineer kangu haitare ko moina kokse putho kedo we have the concrete ka steel ga sa young's modulus si steel na damadam hele ko chawba sidiam concrete yawra sida bone wood concrete so concrete ki di kaina young's modulus se 30 ka tang ne ba steel ki di kaina 200 ne ba aduna di kaidawi ha matam da aina kai gumba sigi mathaki surface mathaki layer siga makhai layer ga steel rod se phumagadi kaidawne have the pot cha deform to tawning aroi aduna ne ko ni yot phummi je sir adudi aduda khatang nate som da su phummi ji di hai som gi duna atopa maram lei adu so hairake ba hajik aina toisina pot si kaino have da pot si compress or kedoba stretch to do adugi matang da ne ba ko ana kedo you have the see steel gi di young's modulus yam chaw ba young's modulus yam chaw ba steel gi di ko young's modulus of steel la kane young's modulus of steel ne ba la ka du gyan dai ta de dai ko aduna 1 second easy chandre aduna si kitang putoke ka muna taw ko this is very important noi the question ji hang electrum ni na knowledge tate hang pasu yai ba ko adugi so aduna kedo we have the aina sigi mathak makha ga zida steel rod myam ama iron rod or steel rod myam hapchal leba hapchal laga kedo we have the sigi soai dai di kedo ni have sidagi aina kai gumba ko thokraba weight se kedo ba iron rod hapa yana si toraga aina sigi sorok sigi sorok se ko thokraba and then some side is kedo ba sumain toraga sigi sorok se ko thoki bata raga di have di kai you know di moi sing je kem kana deba kai you know di som dai force lak to ba leite ba som dai force lak to leite ba kai you know som the gravity ju horizontally kedo ba act out de adu kanamta no horizontally push to wirak to leite ko only force is weight ni or gravity ni adu di kedo ba makha da di vertical force ne una vertically kwai mathak ka kwai makha ga da ina steel rod phumme moini na phagra ni ba stretch to bodo kai na moini yang smu da siam chaw ba som side to di kedo we have da som side ti kem to do leitum kana de una si weight extra weight cha lo thoki ba ta si weight che aina ko thoki ba adu dai di kai shape ta la ni si shape si da la ne ba yan dai ta de ma'am I beam shape ta la ne ba yan ta bro
Sai sir.
tai ko
Tayo sir.
so sumain to ro ga ke do ra kani have the steel rod ma'am ma ke do ba hendu ra kani bu ko so sigi construction ji noina kai gum ma pan da ga chala ga di metro gumba delhi metro or whatever adu gumba da ko moina ne steel na direct si concrete kam ti yaw da steel gi sigi shape se ma'am ma tham block sang tham da into tham ne bu ko adu again concrete yaw ga so sigi shape si da ngata sarak kani ba sigi kai do ma pang ani am kalle ba sigi shape si da sabs gen tai ko si da weight yaw bu se hen lum da ra ga pot si da hen unnecessary oi ba kana de ba si da in weight option ba mapangan kan be henga te ba oina mana oina lumtha ba weight to na maram or still happy but still do the hen stress si henga ale adu so ku si ko tho lang thokim na pa na ko tho si shape si do ni sai ba ko an ni yum sa ba matam da su kai da we have da yot loan ba matam da mathak ka makha gai layer da di yot mam loan ni ba nakan da di hapoi kai nakan da hap da kem kana de ba kai no ni yam sunam kai ni earthquake yam prone ba jaga da lei ba tar ga di nakan da ju ama tang or ju hap pa phai kai no di pot se asom side te ju ke hani sumaina sigi som side te force sumaina la ga nik pa khot pa do kha fa na ba ko so do le adugi ni aduga ngasai gi koina ke do yung na happy du na kai gino habda yung na ju hap ta ya de kai gino habda ngasai compression do weight tu na namdar ka du ni na road to phajana hap traga di potos kai gino di concrete ki di yang mo la si ni me still hapata ga di pak heta namdar pa ya roi du ne ba ko aduna still ji koina happy ne yum sab the yot yaw ba yaw da bu si yot yaw na dum kan ni yot yaw draga di kan loe ko potse gyan dai ta te now yot yaw yot have the still ni ko gyan ta bro hai di noina still la ga noina stainless steel ka tang khan ga nu ko iron na koina sin ai pure iron na ti pure iron di soft oe ba ko still nga ta ne koina sin ai ma'am so sidal loe solids ko mechanical properties of solids ta ko pungoi loe kai kanano doubt labor hairo sahila yabra
Yes, sir.
yareba ko anjali yariba shivani christina lakshmi saitabos kaninglu
Sai. Sai sir.
Yari.
yari ko so mechanical properties of solids ta ko di pungloi lore sida auna sarna pami ji kaina pung ni kya tare 9:30 exactly tare noi pung ni pa chap sana sanga di phodone sarna ek tharak pa ko link to noi hita changak ti ni to
Sai không bị à gì.
yadi ya changba kai yadi jana sen okay do kon energy ko do ke do yadi na do now question number ni solve to ga noi atai angam bagai try to ko so first question je ko the stress strain curves are drawn for two different materials x and y it is observed that the ultimate strain point and the fracture point are close to each other for material x but are far apart from material y we can say that materials x and y are likely to be harga okay fine so okay do we have the material x then yield point ga the ultimate strength point ga fracture point ka je si ji ke do ba ani ji yam nak nei ha ba ko aduga y dan ke do ba yam lap nei ha ba adu erga di karam mani henna brittle loini or karam mani hen takta loini ko so it's a very simple question yeng ko si question ji yengo noi hairo karam bane henna ductile oini ductile oi ba habdi sang na chingthokpa yabado sang na chingthokpa yabadu sang na chingthokpa yabadu na kedoni hab matamda potsi lapna gaduni ko nakna ragadi less ductile oiduni. So we can say that x and y are likely to be acha x ka y ga si likely to be have a ka aduna x to lap nahi hai, right? So observe the ultimate strain point and the fracture point are close to each other for material x and far apart for y. Is it ductile or any x in a kai or any x in a brittle or any ka that can mani na ka brittle or any. So brittle and ductile hai ta option number B jita ani gyan daita de tai ko kai for x it is kai do close to each other ka fracture point ga kai ga ultimate strength point ka kai do are close to each other for x neba on x to the yam sang sing to pa de pat long tat krani on adu brittle ko ko and then far apart for y di yam sang sing to pa on y di ductile or ni ko adu so that's it. Now let's move on to the next question. Question number 2 is adu 2019 gi matungda or 2020 gi matungda hangi bu question le ga di sir da tharo sir dum solve to ge ka matang gi question ji ma tausan ji aina mo kaigino habda noi hayeng de flux ta ko hawning e ko adugine matam do yam leite handaki test sida solids ka fluids ka tawdeni ko so yemo sigise a wire of length L area of cross section A is hanging from a fixed support. The length of the wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus is a very simple question. No issues am gadra
Tawraji sardum.
Tawsalaje buka. Okay, my weight chi kaino mz tarni buka. And then it is so simple magi ke we have the stress by strain do mz is in a force ni area of cross section a ni which is equal to Young's modulus sarga changing the length of the wire changes to L1 have L1 minus L original na L ni divided by L tare adu erga di y do kai tarni y do so simple mgl divided by a harga L1 minus L odi kai tare option number D tare sisi gyan buta hobro noi yarbo myam loina mak gyan ta da mi yaubra Christina gyan tarba Christina tadro
Tare sir.
tare ko Shivani tai ko okay fine kaninglu kena ta hobra yari ba
Oh.
yari ko gyan ta ba ngami ko ngami ko okay fine yari ko adudi saitabo yari ba Lakshmi yari ba
Sir.
Yari buka. Okay, fine. Now let's move on. Next question, Yingzi. Next question is question number 3. When a block of mass M is suspended by a long wire of length L, the length of wire becomes L plus L. The elastic potential energy stored in the extended wire is and have a ka. So ajikta sarna elastic potential energy do. Adu ajikta tawgre ka adu do amuk tawrsi. Sige sina drop mane. So kai tane hai no elastic potential energy di kai tage jita half into moine kai kai piram me have the half into stress ko half into stress into strain la tage dong sai gida
Volume jo dene.
no volume ya organ strain square lagta ne natro
Step.
to sileto half last the volume ya half into stress into strain into volume ko okay fine so very good adu regadi half into stress into strain into kai leni volume so half into stress tube suspended by a long wire of length L so mz divided by a strain di kayo L plus L divided by L into volume di kayo A into L ne buka. Auna A ga kakre, L ga kakre, the half mg L plus L. So moine sida isida amuka kai mg ga, oh sorry, L plus L has, this has to be small L. This has to be small L. L dash minus L haiduneva. So L dash is the L plus L minus L, which is equal to L oiduneva ko. Auna kai tani answer se half into mgl. Kyan daita de? Yarbo me amne ma?
Yani sir.
Yani ko. So this is a very simple ko. Easy way of question ni ko. It's a very easy question. Now let's proceed. Question number 4. Two wires are made of the same material and have the same volume. The first wire has cross-sectional area this, and second wire this. If the length of wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? Sisi sir taura noing amgadra sa haina ro.
Sir.
Okay. Now, CE question sida hai zikena have the two wires are made of the same material. Same material har the Young's modulus manarni ka, and have the same volume. Volume chamane. The first wire has cross-sectional area A, and the second wire has cross-sectional area 3A ka. If the length of the first wire is stretched by delta L on applying a force F haibaka. So ahambagi hantorsi F by A is equal to Y haraga delta L by L nebaka. First kiniko. How much force is needed to stretch? So let's say this is F1. Now F2 gidi F2 by A is again my area of cross section. 3A hai mana 3A. Young's modulus y1 y2 have a lay, right? Needed to stretch the wire by the same amount, I mean the delta L. But what about the length? Same volume lay have nina moina length to pyramid jakuna puthoni ko. A into L should be equal to 3A into L dash never. Oh, the L dash to kai tarni have matamda A ka kreka. So L by 3 tarni. This has to be L by 3. Very simple ka. Adu ibita argadi they want us to find keduba force keduba F2 force puto ko pa me ko F2 in terms. So if I divide F2 by F1, I get A cancel sakre ko F2 by F1 adu di sida 3 la ni ko makha da 3 la ni y cancel sakre blah blah sida cancel sakre. So F2 da di sida 3 la ni ko 3 dang la ni. So it implies F2 is equal to 9 times of F1. So it has to be 9F tar. 9F tar yung ma'am? Yung?
Tay, sir.
Ay ko. So sir na solve to easy. Gyan tahaw bra, tahaw ta bra? No response.
Sir.
Tahaw ko. Okay, fine, great. So aduni yam live ni ko no ID concept sing je gyan butar di no na dum laira kani ko aduga gyan ta draga di lu godoni. So aduna aduduma section law no de ko aduga ID aduga no practice walaga di yaroi ko practice se aduki matik changi da ka lai ko practice taw draga di yaroi. So mathang da question number amakhalo aduga loi selaje question 10 katang ni loi tho je wars one. So the bulk modulus of a spherical object is B if it is subjected to uniform pressure B. The fractional decrease in radius is an I. Sising gadra sir torora, knowing gadra sir I know. Tauzira, Yadra.
Tause.
Kaiba?
Tause.
Ko. Kanang kumay no kangre. Kanang kumay siya. Sa Ilara.
Mani sir.
Okay, yeah. So here, we have the bulk monospherical object is B. If it is subjected to uniform pressure P, so uniform pressure P that the minus B haraga, the fractional decrease in radius have been so do the equation of 4/3 pi. Let's say mazi spherical have 4/3 pi r cube minus 4/3 pi haraga like Saranazi new radius is small r oidinebako. Aduga sige line si so c small r cube divided by kidoba 4/3 pi original volume d r cube nebako. Kay you have the original volume z volume kidoba v not hargeka original volume z or v is equal to 4/3 pi r cube nebako. And then v dash di kay have the v minus delta v nebako. Or you may say have the original volume let's say v dash final volume c currently change the squeeze over so r cube there only delta v the obviously kay 4/3 pi r cube minus whatever original she's the inning the so e kay the moina delta v yare ko sige so sumay negative si sumay anyway now zik we see the in bracket column so 4/3 pi is doing common log toga chat the minus b layer and then we have the r minus the pressure b the fractional decrease in radius 7 all right fine so r cube minus r cube divided by r cube layer ni aduga sisina pressure p force by area so we have something like so the fractional decrease in radius okay all right fine fractional decrease in radius higher p by let's go cube dilakane moina heading ni si si sumaina hotpadi yararoi aduna sumaina ne hotsi yone sarna haji khali ba wakanje si ne ba noina catch to bodo is quite important noise aina hana sumaina khalle moina pirami ba option ji dadi kaim chanadre yararoi je khange ba aduna di muka atopa way ama thirakpa tamne ba atopa way ji kaino ay matamda aina sidai sida change in volume kaiguma thiba taragadi dv je thiba taragadi loina maksi constant ji loina ani 4/3 pi harga kai 3 r square dr lane derivative logo dv by d so si ma khangje lo yare adu iba taragadi hauzik aina kai da si myam loin change so thoni ba sumaina wakhanji khan ba tamgadabane ba khada aduna we have the p is have the p is aina ngasai gi do adu sinaroi in a d sorry my bulk modulus b ma phang ga minus am hap tab dia de moi di minus in da ma ka dv by v ne ba adu erga di minus b erga dv di kaino sida 4/3 pi r square dr and then my v do di kaino have the 4/3 pi r cube ne ba aduna we have matamda 4/3 pi 4/3 pi ka into 4/3 pi erga 3 r square sorry a 3 wala me the 3 wala me so aduna si r square si ka kredi r am le more ne aduna minus b erga dr by r minus 3b dr by r is equal to p adudi moi puthwai je kaina dr by r ne dr by r puthwai ni so a small r sinam phabra anyway small r in sinna di phai but anyway do kai doni have the minus erga p by 3b tarni. So p by 3b yaubra yawiko. So option number C tabre ma'am.
Tayo, sir.
Taiko. So sir na sumay wakanji ahambada sumay walam bada tak laung sida change tawri do khangobra. Khangowi ko. Kay the way change tawino haibada option da yawrok treba ko. Option da yawk tramnina moi ji sina tragadi upai lero do. Adana khan mangam gadabane ba ko. Adugini. So anyway aina sida notation haigadra ko. Si sumayna tawuse singri yadi yade. Auna r j small r ngata sinagi. Kay no di phajade ko lana takshan baji nuaiti haitare. Kay di convention na malay ko. Adugi convention du tu ay de at any cost. Ana si RG logto and then sige RG zo. Come on, storage. R में आमची लोई मुथत क्रॉ अदुगा small r ना लोई मुहत सिंजला का. So this is small r. So this is small r. This is small r and this is small r and this is small r. यारे का अदुगा गए dr by r. यार में हम लोने मुसी किसे? याहू bro?
Sir.
Yes.
याही का?
야오이 sir.
Okay, fine. Audi matang question tawrji ka. Matang question. Question number 5 razik to the manika. Question number 6 yung ka. Question number 6 is the kay hayang zika. The Young's modulus of steel is twice that of brass. Two wires of same length and of same area of cross section, one of steel and another of brass, are suspended from the same roof. If we want the lower ends of the wires to be at the same level, then the weights added to the steel and brass wires must be in the ratio of. Very simple. Now, knowing Start over. Zero yard. Shivani, Kaningu, Lakshmi, Haro. Lakshmi, Haro. Kaningu.
Yarnida, sir. Yarnida.
Okay, Kaningu gidi yarni buka. Lakshmi di. Lakshmi ikta hire mane. Lakshmi kay have no haro.
Okay, sir.
Tause buka. Okay. Saila di. Saila zu. Kanong hining mo mali. Okay, nui maraktagi mi ama hetana tause harga. Kay hano itadre. No is kaya. Kay have no sir do seeing the tadre ka. Mukahara kizu yani. Anyway, tawrji ka. The Young's modulus of steel is twice that of brass. So Young's modulus of steel is twice the Young's modulus of ka. Zumain nere. Dagiti nui kena to noise thokpa ma kananum di thokpa mi yare ka. Okay, fine. Yare. So the Young's modulus of steel is twice that of brass. Two wires of same length and of same area of cross section, one of steel and another of brass, are suspended from the same roof. Everything is same. Can they go? The only thing is Young's modulus can have never. So Young's modulus di kay no have the F by A stress by strain never delta L by L never. So some sites you can have the F by A. Let's say this is F1 and let's say this is F2. Divided by delta L by L never. So loine magchap manahan gi haragadi kay oidino have never 2 ko. It implies F2 is equal to 2 times of F1. That's right. F2 is F1 by 2. F1 by 2. F2 is equal to F1 by 2 tare. Sige matungin ay tare. Natragana nang nasumay na higher su yay 2 times of F1 di laser na ko sa. Aduna mo na ay weights added to the steel and brass wires must be in the ratio hay bako. Steel gidi F1 ni is it? Kay ino in som the F2 erase it. Si F1 o din. Monorators. Aduna kay na have that this is F1 and this is F2. So F1 by F2 is equal to 2:1. Yare ko. 2:1 tabre yung ma'am sige. D tabre yung. ꯌꯦꯡꯉꯣ
ꯇꯥꯏ ꯁꯔ
ꯇꯥꯏꯀꯣ ꯌꯥꯕ꯭ꯔꯥ ꯍꯥꯏꯗꯤ ꯁꯔꯅ ꯁꯣꯜቭ ꯇꯧꯔꯤꯁꯤ ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ꯭ꯔꯥ
ꯍꯣꯏ ꯁꯔ
ꯇꯥꯏ ꯁꯔ
ꯌꯥꯔꯦꯀꯣ okay fine so it's a very simple question ꯀꯣ ꯌꯥꯝ ꯂꯥꯏꯕ question ꯅꯤ so question number kya option gre 6 option graba question number 7 je the approximate depth of an ocean okay si jima sir to be sir tawrge 8 ka 9 ka 10 ni jima si ju dum in to phadra 952 di chale ko si question ne 8 ka 9 ka 10 ga se hayeng tor si ko theng ju theng en ju kotha zero ajik lo shela su yabudi ai but hayeng si tawraga hayeng dum hawrani ko fluid stack ko mechanical properties of fluid stack ko yabra ma'am
yes sir
Yes, sir.
ko okay fine Audi thank you everyone ko have a good night ko good night thank you
Yes, sir.
good night sir
good night